Today we're going to continue our discussion of 4.1, which is an introduction to right triangle trigonometry, by focusing on the inverse trigonometric functions and angles of elevation and depression. Okay. In yesterday's class, we looked at how we can use sine, cosine, and tangent and the 6 trigonometric functions to identify trig ratios given sides and also solve for missing sides. Okay. Today, the inverse trigonometric function allows us to find the measures of an angle in a right triangle. Now, when do you use inverse trigonometric functions? Okay, you use it if you know 2 or more sides of a right triangle and you need to find one or both acute angle measures. Now, how do you use it? So say we have sine theta is equal to x, and the value of x is going to be known. And in order to find your angle theta, we're going to take sine inverse, which is sine to the negative 1 power of our ratio x. Okay, and the same is true for cosine theta equals x and tangent theta equals x. If you know, for example, an adjacent side and the hypotenuse of a right triangle, then you would use cosine inverse of that ratio to find the missing angle. Now here's what it looks like. In example 5, we are going to use a trigonometric function to find the measure of theta. We're going to round to the nearest degree if necessary. That means the nearest whole number. Okay. In letter A, we have a right triangle. We need to find the measure of angle theta. We're given side lengths of 12 and 15.7. Okay. 12 is across from or opposite angle theta, so 12 represents the opposite side, where 15.7 is across from the right angle, so this represents the hypotenuse. Now, if you recall from last class, sine uses the ratio opposite over hypotenuse. So what I know is that sine theta is equal to the opposite side divided by the hypotenuse. Okay, now I'm going to plug in what I know. I know that sine theta is equal to the opposite side is 12 and the hypotenuse is 15.7. Because I'm trying to find the angle theta, I'm going to use sine inverse. So theta is equal to sine inverse of my ratio 12 over 15.7. We cannot calculate this by hand, so take out your calculators. Again, make sure that you are in degree mode. Okay, I have DEG, so I'm in degree mode. Now, above our sine key is sine inverse. It's sine to the negative 1 power. So I have to hit my second key and hit sine. You can see sine inverse appears. Now, in parentheses is 12 divided by 15.7. Use the division key for the fraction rather than a fraction button. So take 12 divided by 15.7. Now, if you hit equal to the nearest whole number, that is 50 degrees. So what I know is that my angle theta is approximately 50 degrees. Okay, let's try letter B. In letter B, I need to find my angle theta. I'm given side lengths 12 and 5. Okay, 12 is my hypotenuse, and 5 is the adjacent side. Now, recall from last lesson that cosine theta is the ratio of the adjacent side to the hypotenuse. Okay. So I'm going to take this and plug in what I know. So I know cosine theta is equal to the adjacent side is 5 and the hypotenuse is 12. In order to find the angle, I need to use cosine inverse. So theta is equal to cosine inverse of the ratio 5/12. So on my calculator, I'm going to hit the second key and cosine, so the cosine inverse appears. And then using my division key, 5 divided by 12, to the nearest degree gives me an angle that's approximately 65 degrees. Very good. Okay. Now, trigonometry has many applications. There's going to be a handful of you in your careers that will use trigonometry on a regular basis. Okay. One way that we apply trig outside of school is using angles of elevation and angles of depression. An angle of elevation is formed by a horizontal line of sight and a line of sight to an object above. Okay. An angle of depression is formed by a horizontal line of sight and a line of sight to an object below. Okay. Now, this is something that is very important, and some of the most missed problems on the Chapter 4 quiz and test will come from angles of depression. Okay, so it's important to understand the definition of these before you try to solve the problem. In example 6, letter C, says the chairlift at a ski resort rises at an angle of 20.75 degrees. Now, where we see that it rises at an angle of 20.75 degrees, this represents an angle of elevation. So notice, okay, where we might have a person standing, there is a horizontal line of sight and a line looking up the chairlift, creating an angle of 20.75 degrees. Okay, while traveling up the side of a mountain, the chairlift attains a vertical height of 1,200 feet. Vertical is straight up and down. Okay, that is why we labeled the vertical height of this right triangle at 1,200 feet. Now we want to know, how far does the chairlift travel up the side of the mountain? Okay, how far is this lift up the side of the mountain? Okay, we know our angle, 20.75 degrees, our angle of elevation. 1,200 feet is the opposite side. And D, the length of the lift, represents my hypotenuse. So in order to find how far the lift travels up the side of the mountain, I'm going to use sine theta, because what I know is that sine theta is equal to the opposite side divided by the hypotenuse. Plug in what you know. So I know that the sine theta is 20.75. The opposite side is 1,200 feet. And the hypotenuse is D. I need to solve this equation for D. So I'm going to multiply both sides by D. I do so on the right side. D's gone. Okay, so I am left with D times the sine of 20.75 is equal to 1,200. Next, I divide both sides by sine of 20.75, so that D is equal to 1,200 divided by the sine of 20.75. So in order to find the length of D, we're going to take 1,200 and divide that by the sine of 20.75. Okay, this makes the length of the lift approximately 3,387 feet. Okay, this represents an example of angle of elevation. Okay, turn the page and we're going to look at an example of angle of depression. All right, it says a group of hikers on a camping trip climbed the top of a 1,500-foot mountain. Okay, so here's our picture. We have campers that climbed to the top of a 1,500-foot mountain. So they're standing up here at the top. When the hikers look down at an angle of depression of 36 degrees, they can see the campsite in the distance. So the hikers are up here. Okay, since they are at the top, they're looking down, we have an angle of depression. Now, the angle of depression is formed by the horizontal line of sight and the line going down. Okay, so notice when we have an angle of depression, it is not located inside of your triangle. It is located outside of your triangle. Now, they want to know the horizontal distance between the campsite and the group to the nearest foot. So we are trying to find x. Now, we need an angle that is inside of the triangle. Now, the angle of depression and the angle inside of the triangle creates a 90-degree angle. So in order to find the angle on the inside, I'm going to take 90 minus 36, and that is equal to 54 degrees. So the angle inside my triangle is 54 degrees. Now, based on 54 degrees, x is the opposite side, and 1,500 is the adjacent side. Opposite side and adjacent side means I'm going to use tangent. So I know that the tangent of 54 degrees is equal to the opposite side is x divided by the adjacent side of 1,500. To solve for x, I'm going to multiply both sides by 1,500. Okay, so I have 1,500 times the tangent of 54 degrees is equal to x. And I have to plug this in my calculator. 1,500 times tangent of 54 degrees. To get the distance, 2,600, or 2,000, it says the nearest foot, so 2,065 feet. Good. Okay, I would like for you to pause the video, and I want you to take a look at letter F and see if you can draw a picture of the situation. Once you have a picture of the situation, go ahead and turn the video back on, push play, and I'll go through this together. Letter F. A sightseer on vacation looks down into a deep canyon using binoculars. The angles of depression to the far bank and near bank of the river below are 61 and 63 degrees respectively. If the canyon is 1,250 feet deep, how wide is the river? Okay. Now, what we have is a sightseer on vacation looking down into a deep canyon. So he's up here at the top, and he is looking down into a canyon. Now, our sightseer sees a river. Okay. Now, he is looking at the near bank and the far bank of the river. Okay, so here is him looking down at the near bank, and here's him looking down at the far bank. Now, these create angles of depression, which means we have to have a horizontal line of sight, okay, of 61 and 63 degrees. So here's 61 degrees, and here's 63 degrees. Now, this creates a right triangle, like so. Now, what we need to determine, if the canyon is 1,250 feet deep, how wide is the river? So what we need to figure out is how wide this river is, and we're going to call this X. Now, what we know is that the canyon is 1,250 feet deep. Now, what has happened is that we have formed two right triangles, okay? Here's the first right triangle, and the second right triangle is the entire picture, okay? Now, the first thing that I'm going to do is I'm going to find this length called Z. I'm just making up the letter Z. It goes from here to here. Okay. Now, I also need the angle inside of this triangle from here to here. So I'm going to take 90 minus 63. Now, if I take 90 minus 63, I get 27 degrees. So the angle inside of this triangle is 27 degrees. Okay, where Z is the opposite side and 1,250 is the adjacent side. So I know that the tangent of 27 degrees is equal to the opposite side divided by the adjacent side. Now to solve for Z, I'm going to multiply both sides by 1,250. So I have 1,250 times tangent of 27 is equal to Z. So I'm going to calculate this. I have 1,250 times tangent 27. I'm having a hard time seeing that. It's 636.9 feet. Okay, so I know the length from here to here is approximately 636.9 feet. Now, the second triangle, okay, is the entire triangle all the way across the river and back up. Now, I know that the angle of depression out here is 61 degrees, so I'm going to take 90 minus 61 to give me the angle inside, which is 29 degrees. Now, what I'm looking for is the entire length of the base. I'm going to call this Y. Okay. Now, Y is the opposite side. Okay, and 1,250 is still the adjacent side. So what I know is that the tangent of 29 degrees is the opposite side, Y, divided by the adjacent side, 1,250. Now to solve for Y, I'm going to multiply both sides by 1,250. So I have 1,250 times the tangent of 29 degrees is equal to Y. Okay, calculate this. So we have 1,250 times the tangent of 29, and it's 692.9. Okay. Now, Z represents the length from the right angle to the near side of the river, and Y represents the length from the right angle all the way across. So in order to find the length of X, I'm going to subtract the length of Y minus Z. and that will give me x, which is the length of just the river. Okay, so I'm sorry. Yeah, so I have 692.9 minus 636.9. Okay, and the length of the river is approximately 56 feet. Very good. Now, this is a more challenging problem. It requires you to identify both triangles, find two missing side lengths on the same side, and then add or subtract to get the length that we are looking for. Okay, all I can say is try a couple of these on your own and make sure you bring some specific questions to class. Okay, the last problems in example 8 is to solve each triangle. This is just kind of wrap up everything from 4.1. Now, when you are asked to solve each triangle, you are asked to find all missing sides and angles. Okay, so solve each triangle means to find all missing sides and angles. Okay, now when you find missing sides, you can either use your trig function, sine, cosine, or tangent, or if you know two of the three sides, like in letter H, you can use the Pythagorean theorem, and it is up to you. Just make sure that you round as the directions tell you. So we're going to round side lengths to the nearest tenth and angle measures to the nearest degree. Okay, so in letter G, okay, I know angle G is 90 degrees, and I know angle F is 41.4 degrees. Now, the first thing I'm going to do is find angle H. I know that all of the angles in a triangle add up to 180 degrees. So I know that angle H is equal to 180 minus the sum of 90 and 41.4. Okay, so on my calculator, I'm just going to take 180 minus 90 minus 41.4. Now, the directions here are specific in that we round the angles the nearest degree. Guys, we're going to make sure our angles add up to 180. So I believe in this case it is okay to let angle H equal 48.6 so that my three angles add up to 180 degrees. Now, if you want to fill that in, you can, or you can find H and G just with the information that's given. Now, using an angle of 41.4, F would be the opposite side, and H would be the adjacent side. Okay. 28 is my hypotenuse. Okay, I'm going to start by finding F, and I'm going to use sine. So I know that the sine of 41.4 degrees is equal to the opposite side divided by the hypotenuse. So I have sine 41.4 equals F divided by 28. To solve this, I'm going to multiply both sides by 28. Okay, the 28's cancel on the right side. So to find F, I'm going to take 28 times the sine of 41.4 degrees, and we get approximately 18.5. So sides are to the nearest tenth. Okay. Now I could plug in 18.5 for F and use that to help me find H, but if you can use what's already given in your picture, I would just stick with that. Okay, now I need to find H, which is the adjacent side, so I'm going to use cosine because cosine is adjacent over hypotenuse. So I know the cosine of 41.4 degrees is equal to the adjacent side divided by the hypotenuse, or h over 28. Again, I'm going to multiply both sides by 28. So I'm going to take 28 times the cosine of 41.4, and that means h is approximately 21.0. Oh, that looks like a 4. Very good. All right, I'm going to have you try letter H, and we will look at letter H next class to check your answers. Make sure you know any questions that you have that I can address in class the next time we meet. Good luck.